Density is a ratio of a object's mass and volume. In fact, it's the formula for it is density equals mass divided by volume. It's how much mass there is, and you divide it by how much space that object takes up. All right. The density does not change. If I've got water, it's 1 gram per cubic centimeter or 1 gram per milliliter, either one. They're both milliliters and cubic centimeters, exact same measurement. No matter how much I have, the ratio stays the same. If I have 1 cubic centimeter of water, all right, then it will equal 1 gram. 1 gram. And if I do the math, if I do the mass divided by volume, well, that equals the density of 1 gram per cubic centimeter. All right. If I had 5 cubic centimeters of water, because this is 1 gram per cubic centimeter, if I had 2 cubic centimeters, it'd be 2 grams. If I had 3 cubic centimeters, it'd be 3 grams. If I had 5 cubic centimeters, it'd be 5 grams. Well, if I had a glass that was 5 grams and 5 cubic centimeters, well, the mass would be 5 grams and the volume would be 5 cubic centimeters. When you do the math, the 5s divide out and it still equals 1 gram per cubic centimeter. It doesn't change the density no matter how much you have. If you chop this piece of wood in half, you don't cut the density in half. It's still 0.5 grams per cubic centimeter. So different objects have different densities. Water is a nice, easy number to remember. We have 1 gram per cubic centimeter. Plastic is like 2 grams per cubic centimeter. Steel is like 7.8 grams. So like with plastic, if I had 1 cubic centimeter, the mass of the object would be 2 grams. If I melted it down and had a block that was 2 cubic centimeters, well, the mass of that block would be 4 grams. That's how density works. Now, the other thing is with density in water, objects that are less dense than water will float. All right, so objects that have a density less than 1, like dry wood or styrofoam cups, they all have a density less than 1. They're going to float on top of water. And objects with a density greater than 1, like steel and nail, 7.8, they will sink to the bottom. So the question is, if plastic has a density of 2 grams, which is greater, why does a rubber ducky float? Well, that's because the average density of it is no longer that of plastic. It's got a lot of air space in it, and air is obviously less dense than water. Here it is floating on top of the water, and there's lots of air in there sitting on top of that water in the cup. So that air in there, you got the same mass for the rubber duck, but you have increased its volume by putting in air. And notice this, whenever you increase the volume of something, if you make this denominator bigger, you're dividing by a bigger and bigger number, it makes your final answer get smaller and smaller. Okay, again, if this volume gets bigger, if I'm dividing by a larger and larger number, as this gets bigger and bigger, if this number goes from 1 to 10 to 100, if I divide by 1,000,000, it would make this final answer get smaller and smaller and smaller the bigger number I'm dividing by. So as volume goes up within an object, if you put a lot of airspace in there, the overall density goes down. And in fact, that's how an aircraft carrier can float on water. It's steel, but there's so much empty space within that aircraft carrier that the overall average density of the ship is less than 1. It's still extremely heavy. There's a lot of steel there, but we're talking about density. Density is what allows an object to float. And if the average density, if you get that volume large enough that the average density is less than 1, it will float on water. The other thing is this, the old adage, what weighs more, a ton of bricks or a ton of feathers or a ton of bricks? Well, they weigh the same. Just the density is different. I would just need a lot more feathers. Here we have an object, they're both 100 grams, but there's a lot more of this object here. Let's say this was a bunch of plastic, 2 grams per cubic centimeter. And so with this, if I had 50 cubic centimeters, it would be 100 grams like we have there. So this would be like 50 cubic centimeters. It's a lot, kind of a sizable portion. Whereas this one, it's much smaller. And say instead of like 2, we had, let's just use a nice round number like 10. Say if we had an object, or there's not one listed up here, but let's say if we had an object that had a density of 10 grams per cubic centimeter. Well, I would only need 10 cubic centimeters of that object to get up to 100. So that's why you got to be careful. You can have different objects, with different densities. They can have the same mass, but if one is smaller, it just doesn't take as much of that object because it's just more dense. It's more compact. It's like putting a brick on there versus some styrofoam.